In this example, we are going to determine the sine of theta over 2 given information about the sine of theta and the quadrant that theta is in. Well, we see right here from this statement, we see that the theta must be an angle somewhere in the fourth quadrant. Okay, now sine theta equals -3 over 5, but we know that sine theta equals y over r. So what we can do is say y over r equals -3 over 5. Since r has to be positive, we can say therefore y is negative, which actually makes sense based on where the terminal arm is. So we're going to say that y equals -3 and r equals 5. Let's find out what x equals. X squared plus y squared equals r squared. So x squared plus -3 quantity squared is equal to 5 quantity squared. X squared plus 9 equals 25, which means x squared equals 16, which means x is equal to 4, but we need to know, do we put a positive sign or negative sign in front of that 4? Well, to figure that out, we look back to this terminal arm. That terminal arm is to the right of the origin. X is positive, so I'm just going to leave it as x equals positive 4. We know r equals 5, so therefore we know that the cos of theta is equal to 4 over 5. Okay, that's important. Now, let's freeze there for a second and now focus on this part, sine of theta over 2. Anytime you're asked for either the sine or cos of theta over 2, the first thing you want to do is begin with the double angle formula for cos. In other words, you want to say cos 2 theta equals blank. If you're asked for the sine of theta over 2, like you are in this question, you're going to put 1 minus 2 sine squared theta. Had I been asked, instead of being asked for sine of theta over 2, had I been asked for cos of theta over 2, then I would have put the version that says 2 cos squared theta minus 1. But that's not what I'm being asked for in this question. I'm being asked for sine of theta over 2, so I use this version of the double angle formula for cos. Now, what I can do next is I can divide the angle on the left-hand side by 2, and that'll just give me theta. So instead of cos 2 theta, it's cos theta. And I can divide the angle on the right-hand side by 2. So instead of saying 1 minus 2 sine squared theta, I can say 1 minus 2 sine squared theta over 2. Now, cos of theta, we just said a minute ago, is 4 over 5. So 4 over 5 is 1 minus 2 sine squared theta over 2. I'm going to add 2 sine squared theta over 2 to both sides. In other words, I'm going to bring it over to the other side there. And I'm going to subtract 4/5 from both sides. In other words, I'm going to bring it over to the other side. So what I get then is 5/5 minus 4/5, which is 1/5. So I've got 2 sine squared theta over 2 equals 1/5. So let's just put that up at the top here. 2 sine squared theta over 2 is equal to 1/5. Now I'm going to divide both sides by 2, and that's going to give me 1/10. And now I'm going to square root. But as you might know by now, I want to know if I should put a positive sign or a negative sign in front of that square root. Well, to help me answer that, let's go back to the last slide and let's look at the portion that I originally circled in this question. 3 pi over 2 less than or equal to theta less than or equal to 2 pi. I'm going to write that down here. 3 pi over 2 less than or equal to theta less than or equal to 2 pi. Well, that's not what I need because the angle in my expression is theta over 2, and the angle in this expression is theta. So that doesn't answer the question for me that I need to know what quadrant it's in. But what I can do, since this is theta over 2 and this is theta, why don't I just divide that theta by 2? So I'll get theta over 2 in the middle. But in order to do that, I have to divide the 3 pi over 2 by 2, which will give me 3 pi over 4. And I have to divide the 2 pi by 2, which will give me pi. So I've got 3 pi over 4 less than or equal to theta over 2 less than or equal to pi. That's like saying 135 is less than or equal to theta over 2 is less than or equal to 180. In other words, it's telling me my terminal arm is out here somewhere. Okay, now, terminal arm that's out there is above the origin. That means the sign, the y-coordinate, will be positive. So that means over here, when I'm taken the square root, I can just leave it as positive the square root of 1 over 10. Well, that's equal to root 1 over root 10, which is 1 over root 10. I can multiply numerator and denominator by the square root of 10 and get my final answer that the sine of theta over 2 is equal to root 10 over 10.